So here's the electronic side of everything. When I press this button here, it'll simulate the M17 output from the control to start the process of switching to the next chunk of code. I hoped that I could easily tap into the control's spare outputs via a relay or something, but the connection manual only states that M code outputs are transistor outputs represented by two 4-bit numbers. I think I can tap into these outputs directly from the control, but it makes things more complicated. Of course, the M17 output is going to be in binary, so I would have to construct some logic gates to get a simple output for the Arduino's trigger. Right now, the cycle start button is based on a timer. I set it to go off after 16 seconds, which is the amount of time it takes 9,000 bytes to transmit at 4,800 baud. I don't really like this timer solution, as if for any reason the next chunk is not imported correctly, the Arduino will push start regardless. A much more elegant solution would be to get some sort of ready signal from either the computer or control that tells the Arduino it's time to push start. I think I can pull this information from the serial connection between the computer and the control. So as you can see here, we have a shortened example of the G-code file that would be loaded into the machine. It begins normal with a %, the address or name of the program, and it goes and it goes and it goes until it eventually reaches the M17 trigger, which the computer program that I'm going to call the post processor will know to insert at the end of each chunk. This trigger sends an output to the Arduino and tells it to begin the program swapping process. The computer that's drip feeding is waiting right here at the beginning of the second chunk, as the % separate the two chunks. The second chunk is then read in. As you can see here, I have a G-code file, and this G-code file is 14 kilobytes long, so it's going to take at least 2 chunks to get this whole file executed. So I haven't used any program to split the file yet, but I've done it manually. Now you'll see here, right in the middle of the program, before the control runs out of memory, there's a %. Now in Fanuc controls, the % denotes the end of a program and the beginning of a program. There's usually a % at the beginning and the end of a G-code file. So the first % that you see, this tells the control to stop accepting data. It essentially says that this is the end of the program. I set the timeout period for my DNC software to be really high, so it'll just sit there in limbo and stand by until the control has executed the first chunk, at which point the Arduino will go through the process of deleting the old chunk and opening up the serial port by pressing the input key, at which point the pointer, or the cursor, or whatever you want to call it, will be right here at the second %. This will denote the beginning of the next chunk. And there's also a program name here. So let's show this in action. So I'm going to send that file to the Accumill. Now you see it's going to stand by. It will not send anything until I press the input key, at which point the clear to send signal will go to the computer and it'll start transmitting data. Now it's going to stop at 71% because the control can only hold 71% of this program. So there, it stopped, and now the program is in memory. It can now execute this G-code all the way to the end, at which point the machine will stand in limbo. Say the spindle's over here, and it's just gonna stop. It'll just sit there and spin forever. So now what's going to happen, the Arduino is going to delete everything in memory by typing in O-9999 and pressing delete, which clears all the memory. And then it's going to hit input. at which point the next program will be loaded in. And then you can see it loading in there now. And once that's done, there's the second chunk.